Okay, in this chapter, we're studying conic sections, and we mentioned in class that a conic section is just a section formed by the intersection of a double right cone and a plane. And I showed you that video that sort of showed you the four different types of conic sections that you could get. You could get a circle, um, which is when a plane intersects a cone and is sort of parallel to that base. You could get an ellipse where the plane sort of intersects one of the cones but does not intersect at the base. You get a parabola if a plane intersects a cone and it intersects at the base. And then you could get a hyperbola if a plane intersects both of the cones. So in this first section, we're going to study circles. And if just going back here, if you forgot about these conic sections, the YouTube link is on my site. You can go and rewatch that. So in this section, we're going to focus on the sort of the first conic section that is listed there. We're going to start with the circle. And a circle is basically just a set of points that are all the same distance from the center of the circle, which we're going to call the point h comma k. So the point h comma k, as I just mentioned, is the center of the circle. So here's the center of the circle, and it's denoted by the point hk. This line from this point on the circle to another point on the circle, which here we're going to call the point x comma y. This line, the distance here is called r, or the radius. So this line represents the radius. So the distance formula, we're going to use that to sort of help us derive the equation of a circle. So in this example, they tell you to use the distance formula, which is given to you here, to write the equation of the circle with center 4, 2, and radius r equals 7. So you need to refer to the graph that they gave you. Here, it looks like this is definitely the center. If you go right 4 up 2, you are at the center of the circle. So this is the point 4 comma 2. R is the distance between the center and a point on the circle. So we're going to call this point xy, and we know r is 7. So they're asking you to use the distance formula to write the equation of the circle. So let's just go ahead and copy it down. D equals the square root of, and let's go ahead and label these points before we start filling out what's underneath that square root bar. The point 4, 2, which is the center of the circle, let's just go ahead and call that the point x1, y1, because that's the point that's given to us. So that's why we're calling it x1, y1. And then the point that's sort of on the circle, we're going to call it x2, y2, which in this case is the point xy. So now when we go to use the distance formula here, we would have x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So we're trying to find the distance from the point 4, 2 to the point xy. So from the center to the point on the circle, which is the point xy. So rather than writing d, we could write 7, because we know the distance from the point 4, 2 to the point xy has to be 7. So in a sense, your distance is really the radius, or r. So 7 equals, underneath the square root bar, we have x2 minus x1. Well, if we refer back to our drawing of the circle here, the point x2 corresponds with the point x. So instead of writing x2, we're going to write x. Then bringing down the minus sign, minus, the point x1 corresponds to 4. And that's going to be x minus 4 quantity squared. Plus, just copying down the plus sign from the distance formula, y2, which we know based on our graph of the circle, y2 is corresponding with y. And then just bringing down the minus from the parentheses above, y1 we said was 2. So that's quantity squared as well. So we have the square root of x minus 4 quantity squared plus y minus 2 quantity squared. So we have all that under the square root, and that equals 7. Which, I mean, this is a nice start. The one last thing we need to do is get rid of the square root symbol. And the way we get rid of square roots is by taking the square of each side. So we would have 7 squared equals, these would essentially like cancel each other out. So your square root sign would go away, and so would your power of 2. So this would be 7 squared equals x minus 4 to the power of 2 plus y minus 2 to the power of 2. And you could simplify that. You could say this is 49 equals x minus 4 to the power of 2 plus y minus 2 to the power of 2. And this would be the equation of your circle. So what did we do there? What we've essentially done is sort of prove that we can use the distance formula to find the equation of a circle. But it'll be kind of tedious to have to use this distance formula every time we want to find the equation of a circle. So an easier way to write the equation of a circle is by using the given formula. So the given formula that your book is going to use is this one right here. It's x minus h quantity squared plus y minus k quantity squared equals r squared. So what h and k would be the points of your center of your circle. So the center is h comma k and the radius is r. So you would just plug in your h value, your k value, and your r value to that equation. The same would be true if you wanted to use this equation, which is essentially just the distance formula. So let's look at example 2. Find the equation of a circle with center 2, 5 and radius r equals 3. Graph the circle. So, and we'll come back to this when we graph. So the equation of a circle, if you look above on your sheet there, is r squared equals x minus h quantity squared plus y minus k quantity squared. We know what r is in this case. In this case, r is 3. So we have 3 squared equals. We know what h and k is because we're given the center of the circle is 2 comma 5. So 2 comma 5, and we have center hk. Your h value would be 2. So this would be x minus 2 quantity squared plus your k value, which is 5. So y minus 5 quantity squared. And we could leave it like that. So now they ask us to graph it. So when we graph a circle, we always start with graphing the center. So the center is 2, 5. So I'm going to go 2 on my x, and then up 5 on the y, and put a point. So this is my center. So to plot a circle, since every point on a circle is the same distance from the center of a circle, if we count up the number of the radius, which in this case is 3, that would correspond to 1 point on the edge of our circle. So you start at the center and you go up 3. You could also go down 3. So if we start at the center and go down 3, we are also at another point that would be on our circle. So we have gone up and we've gone down. We could also go left 3. So this would be 1, 2, 3. And we could also go right 3 from the center. When you're done, connect those 4 dots that you just made, and you have a good sketch of your circle. So this would be the graph of the circle with center 2, 5. In example 3 here, they want you to find the equation of a circle with center -3, 5 and containing the point 9, 10. So what we're going to want to use is one of the equations for a circle. The one thing that we don't know in this example is we don't know the radius. So we want to determine first what the radius is, because after we find the radius, we already know what the center is. They say it's -3, 5. So if we go back up and we look, the second form of the equation of a circle is this r equals the square root of x minus h squared plus y minus k squared. So we're going to use that to determine the radius, because this will give us what r is. So in example 3, I'm going to use this equation to determine r. So r is the square root of, now here our point, we have the center, which is going to be hk, and we have this point 9, 10, which is going to act as the point x comma y. Oops. So 9, 10 is acting as the point x, y. So in that form above, you have r is the square root of x. Well, we know x is 9, minus h. H is -3. So we're going to say minus -3 quantity squared plus y. Well, we know what y is. Y is 10 minus k. K is 5. So 10 minus 5 quantity squared. And we're going to take the square root of this. So simplifying, we have r is the square root. 9 minus -3, these negatives become pluses. So 9 minus -3 is 12. So that would be 12 squared plus 10 minus 5 is 5. So you have 12 squared plus 5 squared, in which you could do that. 12 squared is 144. So r is the square root of 144 plus 5 squared is 25. Now the temptation here, after you simplify, so 144 plus 25 is a square root of 169. So the temptation here is to say, oh, well, just take the square root of 169, and you would find that that's 13, which that would help. You could do that if you wanted to. But if we want to know what r squared is. So in order to figure out what r squared is, you would have to take the square of both sides, just like we did in the earlier problem. In example 1, we had to square both sides so that we could figure out what r squared is. So in this case, r squared is 169, which is true. You could say r is 13, but this gives us a more exact answer. So r squared is 169. So now we figured out what our radius squared is. So we can use that with the equation of a circle, which, just looking above on your sheet, is r squared equals x minus h quantity squared plus y minus k quantity squared. Now we know what r squared is. R squared is 169. We're going to leave x as x. We're not going to plug in the 9. We're just going to leave x as x. We know h is -3. And we're going to put plus. And again, we're not going to plug in the point 10 because we used that point already to help us find what our radius was. So we're going to say y minus, but we are going to put in the k value, which is 5. So it'll be y minus 5 quantity squared. So simplifying this and cleaning it up, you have 169 equals x plus 3 quantity squared plus y minus 5 quantity squared. And this is the equation of your circle. So this is what they were asking for. Example 4, they ask you to write the equation of the circle, oops, sorry, below. So you're given a circle. They clearly identify this point right here as a center, which is the point 0, 0. So you can easily determine how far out your radius goes by just counting either up how many units up you go, or how many units right you go, or how many units down you go, or how many units left you go. That will tell you your radius. Remember, we used that to do example 2. We said if we know the radius, we can determine any point to the right, to the left, up or down. So that's what we're going to do. So we're going to first find the radius. So in this case, your radius, or your r, equals, so we'll just count. This would be 2, this is 4, this is 6, and this point here would be 8. So your radius is 8. The center is at 0, 0. And I just got that because this is the center. This is the bolded dot that they gave you. So if I'm given the center, I can easily, and I'm given the radius, I can easily figure out the equation because I know that the equation of a circle is r squared is x minus h quantity squared plus y minus k quantity squared. So I know what r is. R is 8 in this case. I'm going to leave x because I don't know what x is, but I know the circle has a center at 0, 0. So I'm going to let this point, the center, remember, is always the point h comma k. So instead of h, I'm going to have minus 0 squared plus y minus 0 quantity squared, because the center is at 0, 0. So 8 squared, we know that is 64. X minus 0 is just going to be x to the power of 2 squared. And then y minus 0 is just y, so this is going to be y squared. So the equation of the circle here is 64 equals x squared plus y squared. Your last example here asked you to use a complete the square method. So in this case, you have to use complete the square twice because you have x squared and 2x here, and you have y squared and minus 4y. So I'm just going to rewrite this to regroup. So I'm going to write x squared plus 2x, and I'm just regrouping so that my terms that have x's are with each other and my terms that have y's are with each other. So this is x squared plus 2x plus y squared minus 4y, and that still has to equal 36. Now I can complete the square. I had to complete the square for the x's, and then I had to complete the square for the y's. So if you forget how to complete the square, I have that handout for you, and you can use that to refresh yourself. But if we complete the square on x squared plus 2x, remember your b value here is 2. So we're going to do b divided by 2, which is 2 divided by 2, which is 1. And we're going to square your b divided by 2 value. So that's 1 squared, which is 1. We're going to do the same game here for the y's. So here b is not, this time it's negative 4. B divided by 2 is negative 4 divided by 2, which is negative 2. B divided by 2 squared is negative 2 squared, which is 4. So we're going to use all this information to help us find the equation of the circle. So this is x squared plus 2x, and I'm going to add 1 here because that would complete the square for your x's, and I'm going to put plus y squared minus 4y, and I'm going to add 4 here because that would complete the square for your y's. And this has to equal 36. But now remember, I added 1 here and I added 4 here. So if I'm going to keep this equation balanced, I need to add 1 and then add 4 because this will keep the equation balanced. You can't add, basically you can't add 5 because 1 and 4 is 5. You can't add 5 to this side, but not to this side. So if I'm adding 5 here, I need to add 5 here. So the quick method to factoring this we discussed in class is x plus b divided by 2 quantity squared plus this. In this case, we're going to have y plus b divided by 2 squared. And that equals 36 plus 5 is going to give you 41. And we're just going to plug in our v values here. So this is going to be x plus, in this case, for your x's, your b value was 2. So that will be 2 divided by 2 squared, or quantity squared, plus y, plus, and then with our y's, our b value was negative 4. So I'll put plus negative 4 divided by 2, and that whole quantity gets squared. That equals 41. One last final thing we can do is simplify this. So this is going to be, we know 2 divided by 2 is 1. So x plus 1 quantity squared plus negative 4 divided by 2 is negative 2. So I can write y minus 2 quantity squared, and that is 41. So that is how you would answer example number 5 using the complete the square method. And that's really the only method that we have that we can use to figure out the equation of this circle with the given information that we had. We only could complete the square here. So if you still have questions, please bring them to class with you, and hopefully this helps you with your homework if needed.